Hello, lovely people. Welcome to today's session, students. Today, we shall be continuing from our Python collections. And the last time we met, we discussed lists. So today, we shall be looking as to how to use Python on sets. So our topic for today will be on sets. So at the end of the day, you should be able to use Python to perform the sets that you know in mathematics, if I can simply put it in that way. So let's bring our objective out for today. So now we are saying that at the end of this session, that is this lesson, whoever is following this course or this session should be able to understand Python what says and then demonstrate it in what? In real life what? Environment. So already we all know sets, we learn sets in mathematics. So it's just a matter of we implementing it in what? In Python, so that we will understand the power of what? Using what? Python programming what? Language. So let's get to our theory section so that we will understand what a set is in Python, and then after which we then go into what? The demonstration, how we can then perform sets what? Tasks in what? In Python. So let me bring my notes out so that we can just read it up. And this is a note that I made for myself and for you guys. And it is what is a set in Python. So a set is an unordered collection of what? Items. So this word is what? Is very key. Unordered. So it means that you can set your set, but it's supposed not to what? To be ordered. Every element is unique. So it means that when you are setting it, any element should be what? Unique. There shouldn't be what? Any duplicate. Your item should not be what? Should not be what? Duplicated. And then, and it might be what? Immutable. And this immutable simply means that it cannot be what? Be changed. So this is how you're supposed to set what? Your set. And this is what Python is telling us when it comes to what? Sets. Now, however, the set itself is what? Mutable. So this is what they are telling us, that the set itself is what? Mutable. But then, once we are going to use Python to perform sets, then we're supposed to make it what? Immutable. Not able to what? To change it, because we want to maintain the what? The values. Now sets can be used to perform mathematical what? Sets operation, like what? Union. Like we all know. We can what? We can combine A and B to get what? A union of a set. The intersection also means that we can look through what? A and B and find out which members are in both A at the same time what? B. Then symmetric what? Differences. So now here you want to find only what? A or only what? B. And then we also have complement. So all these things we shall be what? Learning it. And you can find detailed notes on what? On this site. So you can go to this site and then you get details what? Definitions and the explanations to what? To Python what? Says. So now this is the theory aspect of it. And then so let's now dive into what? The demonstration. So bring out your what? Your patcher as usual. So this is my patcher. I've created my folder, and the folder name is what? Says. And then inside that folder, I've created what? My Python file, which is python6.py. So this is where we are going to perform all the demonstrations. Now, so in says, we should all understand certain keyword elements. First, let me bring this picture out so that we can analyze certain things. We all know this, we've seen this type of pictures before. So this is just a sample of what two sets were problem. Now, we have the union, we have the intersection, we have only A, we have only B, and we can even find complement of what? Each. So this is what we are going to perform. So the lesson is going to be short, but then very interesting. And after this lesson, you should be able to explore more, use your mathematical skills to perform the other ones that we may not cover. But then what we are going to cover will be sufficient enough for you to now take yourself to the next level when it comes to what Python says. So now let's go and then declare our variable. So now we have set A. I always say you should make your your variable descriptive. So let's say set A, set underscore A. So if set A is equal to, and in Python, set will bring the same curly bracket. So unlike math, we use the curly bracket. Is in Python too, we use the same curly bracket when setting our set. So set A is equal to, so let's put maybe even numbers. So even number we have 2, 4, 6, 8, and 10. Then let's also set our set B, set underscore B will be equal to, then we have, let's set it to what? Odd numbers. So 1, 2, 1, 3, 5, 7, 9. So our odd numbers are 1, 3, 5, 7, and 9. So now, if we want to find the union of set A and set B, we use a symbol called pipe, and this is the symbol we use. The vertical line, we call it pipe in real life. So for instance, when you are working with terminals and they say pipe, it means that we are talking about a vertical line. So if we want to find the union of set A and set B, then it's straightforward. We just say print. We bring the built-in function and we say set A, then space. You bring your pipe. This pipe will combine both set A and set B together. Then set B. So, and when we run this program, then both set A and set B will be what? Will be combined together. So let's run it and see. Run. Guys, you can see. So our output is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It means that both set A and set B has been what? Has been combined together. So this is what? Union of a set. And that's just all. Now, if we want to perform intersection, values that are in A at the same time in B, union, I say union, intersection of what? A and B, values that you can find in set A, and then you can find the same values in set B. We call it union of a what? Of a set. Sorry. I don't know what is happening to me, guys. But then we said values that can be found on set A and can be found on set B are called intersection of a what? Of a set. It is late here. It's somewhere 12 a.m. in the morning. So I'm now doing the recording. So I'm tired. But then I just want to bring this material out so that you people can start learning something. So now when we say print set A and then we bring this ampersand and then set B, it means that we are going to get the intersection of what? Set A and what? Set B. And we can see we'll get what? An empty set for intersection of set A and set B, because set A is what? Even numbers, and set B is odd numbers. And all the members in set A cannot be found in what? Set B, and the vice versa. So when we generate it, when we run our program, we should get what? An empty what? Set. But then let's run it. Now you can see it has returned what? An empty what? Set to us. So it means that there's no elements in both what? Set A and set B that are common. Now, if we now want to find the difference in set A, then a geometry bring your minus sign. So it means that we want to find elements that are in set A and are not in set B. So let's run our program. And you can see that all members in set A cannot be found in what? In set B. And the vice versa, if we turn this whole thing as set B minus set A, then when we run it, we should get all B members. So let's run it. And you can see we have all our what? All numbers. So let's try and make it in such a way that we can find some elements in both set A and set B. So let's set set A to be prime numbers. So prime numbers start with 2, 3, 5, 7. 9 is not a prime number, and for that matter, we are stopping at what? 7. So let's now find the union. So we bring our pipe in between it, the two sets, and then we run our program. And you can see it has generated 1, 2, 3, 5, 7, and 9. So it means that it has combined both set A and set B. Now let's now find for the intersection. We bring our bouncer, then let's run it. And guys, you can see members that are in set A and at the same time set B are what? 3, because we can find 3 here and we can find 3 in set B2. We can find 7 and then 5 in both what sets. So it means that 3, 5, 7 are in both what sets. So this symbol is the most important thing for intersection. And then the pipe is for what? The union. And that is the most important thing. Now let's find only what? Only B. So by using the minus sign, so when we run the program, you can see that if you take off members that are in set A at the end they are in set B, the one left will what? 1 and what? 9. Because 1 is in set B, but 1 is not in set what? Set A. And 9 too is in set B, and 9 is not in set what? Set A. So now let's find the difference of only set B. So it means that we have set A minus set B. So let's run our program. And it means that it is only, so set A, to find only set A. So it means that 2 is here, but 2 is not in what? In set B. So it means that the only difference between set A and set B is the what? Is the 2. The rest, 3, 5, 7, can be found in what? In set B. And that's why when we were looking for intersection of set A and set B, we had what? 3, 5, and what? 7. Now, let's add universal set to it, and then we find complement of what? A. So let's come here. Let me bring our union, U. Then let's set U to 1, 2, 3, 4, 5, 6, 7, 8, 9. And it is a must to always bring what? The comma in between the numbers. So let's add last one, 10. So our union is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And set A is what? 2, 3, 5, 7. And set B is 1, 3, 5, 7, 9. So now, if we want to find A complement, then we have to use the arrow up symbol. So if you press on Shift and then number 6, you will get the symbol there. So you check on your keyboard very well, and then you can press the 2 key combination to get this symbol out. Then U. So it means that we want to find A complement. So let's generate it. Let's print. And A complement, it means that 1 is in the universal set, but then it's not in what? Set A. Complement simply means that says that as long as set A, all members in set A can be found in the what? In the universal set. But all members in the universal set are not in what? In set A. So numbers or members that are in the universal set but cannot be found on set A is called a complement of a set. So that's why we are having 2, 4, 6, 8, 9, 10. 1, 2, 6, 8, 9, 10. So you can see all these numbers cannot be found in what? In set A. So to find B complement, just take off the A and put letter B. So then let's run the program. And guys, you can see B complement is what? 2, 4, 6, 8, and what? 12. So this is all about what? Sets. So you can use Python to perform what? Basic what? Sets, and even complex ones. So explore on it, and then you'll be genius when it comes to what? Python what? Sets. So enjoy the rest of your night, and then I'll see you tomorrow. Thank you for watching.